All right, so here we're looking at transformations. Now, transformations are just a way of moving a shape around a surface, like a coordinate grid, for example. And there are 4 types of transformations, and what I'm going to do is just talk through one example of each type of transformation. The first one we'll start with is a translation, which is where you just move the shape. You just slide it from one point to another point. You're going to be given a vector, that's what this is, and that tells you how far to move your shape. A really common mistake is for people to read this as a coordinate, like this, but it's not a coordinate, it's a vector. It tells you how far to move the shape. It doesn't tell you where to move it to, it tells you how far to move it. Now the first number, a bit like a coordinate actually, but the first number tells you how far left or right to move your shape. So if we pick any point, I'm going to pick the top point here. We're told to move it 5, but because it's negative, it's 5 to the left, a little bit like a coordinate. So we're going to take this one point that I've picked and move it 5 squares to the left. So 1, 2, 3, 4, 5. And the second number, the one that's on the bottom, tells you how far up or down to move the shape. And again, because it's positive, you're going up, because that's what happens with a grid. Positive is up. So we'll move it 2 squares up. 1, 2, and that is where my new copy of that corner needs to go. And I could just draw the entire shape from there. I can see that the triangle is 2 squares high, so I can see that the next corner is going to go here. And I can see that the bottom right corner is 1 square across from that, so the next corner is here. And that's enough to draw out my shape. But if it's a more complicated shape, it is absolutely fine to take another corner and move it 5 squares left and 2 squares up. And let's just prove that that works. Let's pick this corner. We'll move it 5 squares left, 1, 2, 3, 4, 5, and 2 squares up. And look at that. That is where we thought the corner should go. That's a translation. The next one we'll talk about is a reflection, which is exactly what you think it is. It's where you take a shape like this and reflect it. And the important thing is where the line goes that you're reflecting it. So in this question, we're told to reflect the shape in the line y equals 1. Now, where to draw that line is its own topic, it's its own separate topic, but for the sake of this, let's just remind you, the line y equals 1 crosses the y-axis, which is the vertical axis. It crosses the y-axis at 1, so the line y equals 1 goes across like this. Sometimes they won't give you an equation, sometimes they'll just put the line on the grid for you, or do it some other way, but in this case, we have to draw the reflection line in ourselves. And there's lots of different ways of then knowing where to copy that shape to, where the reflection goes. But one way that might seem a bit clunky, but it will make sure you don't make a mistake, is to take a corner. So let's take this top one up here. We're going to see how far away it is from the reflection line. It's 1, 2, 3 squares away. So the copy of that corner needs to be 3 squares away on the opposite side. So it's going to go here. If we pick another corner, if we pick this one, it used to be 1 square away, so it needs to be 1 square away on the other side, which puts it here. And finally, this right-angled corner is 1, 2, 3 squares away before, so it's 1, 2, 3 squares away now, which means our shape needs to go like this, like that. And that's a reflection, so count the number of squares away that it was before, how many squares away from the reflection line it was before, and then copy it that many squares onto the other side. The next type of transformation is a rotation, and this one's very hands-on, and I recommend that you use tracing paper for it, and I'll try and show you what that would look like. So we're given the angle, we're given how far to rotate it, we're given which direction to rotate it, and we're given where to rotate it around. And that is important, because if you rotate a shape around this point, it moves like this. Whereas if you rotate it around this point, it moves like that. So the place where it ends up each time is different depending on the center of enlargement, which is what this thing is called. It's the center, sorry, not enlargement, it's the center of rotation. Sometimes called the, what else is it called? I can't think of what else it's called. It'll come back to me. So what we're going to do is we're going to put a piece of tracing paper over the top of our shape and draw our shape out. And you can see there as well that I've marked the center of rotation on my tracing paper. So what I've got drawn on my tracing paper is this X and my original shape. what you're then going to do is put a pin, or stab that cross, the center of enlargement, center of rotation, with your pen or something else sharp, and you're going to spin the tracing paper, keeping that point jabbed into your paper. And what that looks like is a bit like this. So we rotated that entire sheet of paper using our pen on the rotation point. We rotated our entire tracing paper and the shape 90 degrees clockwise. And you can see from where it's ended up there, where the shape needs to end up. So move the tracing paper out of the way and draw the shape in. Let me see if I can show you that whole thing again. So we put our center of rotation, the coordinate 2, 1, on our grid, put some tracing paper over the top, and draw your shape on, your original shape. You then spin your tracing paper using a pen or something to pin the paper to pin your tracing paper to your grid, your graph paper, and rotate the paper around 90 degrees clockwise in this example, and then draw the shape where it's ended up. And the final type of transformation is an enlargement. And there are different ways of doing these, but I'm just going to show you one. So we want to enlarge the shape by a scale factor of 2 with a center 3, 3. Now, a bit like the rotation, that center of enlargement, does make a difference to where our new large shape ends up. So we've got that as a piece of information, and we've got the scale factor. Now, a scale factor of 2 means that our new shape is going to be twice as big as the old one. So instead of being 1 square wide, it's going to end up being 2 squares wide. Instead of being 2 squares high, it's going to end up being 4 squares high. Now, our center of enlargement, 3, 3, is here. And the way that I like to do these is to see how far away each point is from the center of enlargement, and then make it twice as far away. So I can see, for example, that this point here is one diagonal square. It's exactly one diagonal square away from our center of enlargement. So the copy needs to be 2 diagonal squares away. So all the way across here is now 2 diagonal squares, which means that's where the copy needs to end up. Moving on to the next corner, let's do the top one. It's not a perfect diagonal this time, so perhaps this time I'll try it by counting squares. That corner used to be 1 square up and 2 squares to the left. So the copy needs to be 2 squares up and 4 squares to the left, which puts it here. And if you were thinking about it as diagonals, you might be able to see that it's sort of twice as far away, a bit like that. And we have one final corner left. We have this one here. And again, if I count squares, it used to be 2 squares to the left and 1 down. So our enlarged copy needs to be 2 times as far away. So instead of 2 squares across, it's now 4 squares across. And instead of 1 square down, it's now 2 squares down, which puts it here. And again, if you were thinking about it as a kind of diagonal lines, you'd see it a bit more like that. So we have our new copies. We have this corner, and this corner. So we draw them in, and we'll just double check that it's the right size, because we said earlier that it should be, instead of 1 square wide like the original, the copy needs to be 2 squares wide. And instead of 2 squares high like the original, the copy needs to be 4 squares high, because each of those is twice as big. So that's all the different types of transformation. There was only one example of each of them, but I hope that's given you an overview of how to execute different transformations. I hope that's helped.